So this is a question from I would say electricity as well as magnetism, because they have given mu naught also. So just read the question. So given a charge Q, current I, and permeability of vacuum mu naught, which of the following quantity has the dimension of momentum? Okay. So it is actually a problem from dimensional analysis, but you have to have the knowledge of, as I said, magnetism, current, electricity, and it's just basic knowledge like about their units. That's it. Okay. So let us understand. We have to find out the relation between mu naught qi such that their unit or dimension is same as momentum, right? So as we know that momentum has a dimension, if we see momentum denoted by P has a dimension m l t minus 1, or unit wise also you can write down it is kg meter per second, something like this. So now, and we have to write down the dimension of this also. So dimension of q is I times t, right, where I is the current. Dimension of I would write I itself, and in some books you will see it is also written as A. So let's not write A here, we have chosen I. Now the dimension of mu naught is important. So how you will find out the dimension of mu naught? So ideally you should remember this dimension, but if you don't know, so you will find out the formulas. You will check on some formulas, some easy formulas through which you can find out the dimension of mu naught. So as far as one small formula is there, as far as finding the dimension of mu naught is concerned. We will use a small formula, that is B is equal to mu naught Ni. So this is the magnetic field inside a solenoid having n turns per unit length. So if you look here, mu naught is here B by Ni, right? And B is Tesla, N is number of turns per unit length. Number of turns is just a number, no unit. Per unit length means per meter, so it will go in the numerator. Okay, some number per unit length. And I means we can call it as ampere. So it is magnitude is Tesla meter per ampere, or else we can write down it as so let's call it as Tesla meter per ampere. Now what we will do is we'll try to decode Tesla also, right? So Tesla is the unit of magnetic field intensity. So as you can see, again we will find some more formula so that everything comes in terms of kg meter per second. Okay, so that's why we are doing all this. So as we have one more formula, Lorentz force F is equal to QVB, right? So I'm ignoring sine theta now because that has no unit. So it is QVB. So B is basically F by QV, correct? So F is Newton, Q is nothing but ampere into second, right? I'm writing just the unit, and velocity is meter per second. Okay. Now again we will further break it down. So if you break it down, Newton could be written as kg meter per second square, correct? Whereas this could be written as second itself. This is ampere into second, and this is meter. So cancel out the things that are actually cancelling out. So we are left with kg per ampere per second square, something like this. So this is for B, right, the unit of B, but we have to find out the unit of mu naught. So hence mu naught will be Tesla. And so in place of Tesla I can write this, right? In place of Tesla, this is the basic unit, correct? So Tesla is a kind of derived unit. Okay, so it's kg per ampere per second square, I can write like this. Then we have a meter, then per ampere. So it would be like kg, this ampere will go down, it will become per ampere square, but 1 meter is there, so kg meter per second square per ampere square, right? So this is the unit of I would say mu naught. Okay, let us convert into dimension. So kg is for mass, meter is for length, second is for time, and let's ia be I. So I minus 2. So this is the way of finding the dimension of mu naught. Although there could be easier way also, you can check for that, but at this point of time it came into my mind, so I did that. Okay, so but ideally you should remember it. Okay, because mu naught is an important quantity, you will encounter it again and again, so you should remember this. So now what will happen, uh, we have to arrange, or we have to find the relation between qi and mu, so that their dimension is as same as momentum. So again what we will do, we will just go through this dimensional analysis thing, so which we know that this dimension of momentum, which is m l t minus 1, it should be same as the dimension of, let's say, mu naught to the power x per se, or q to the power y, or I to the power z or z. So here, so if we further expand this mu naught, so we can write it as m l t minus 2 I minus 2, right, to the power whole to the power x. Then we can write q could be written as I times t to the power y, and I could be written as I to the power z. So if we further solve it, it turns out to be m to the power x, and there is nowhere L we can find out, so L is only to the power x, but we have lot of t here, you can see, right, I times t. So one is t to the power minus 2 times x, another t is there, so power will be added, so it is plus y. And if we consider I, so we have again 3 places where I we have. So for I we can write down minus 2x, then plus y, then plus z, right? So if you look at it, so if you look at it, m to the power 1 on the left hand side is equal to m to the power x. We'll just equate the bases, okay? So that their power will be same. So x is equal to 1. Next, L to the power 1 is equated with again L to the power x, so again x is 1. Next thing is t to the power minus 2x plus y is equated with t to the power minus 1 here. So t to the power minus 1 is equal to t to the power minus 2x plus y. So minus 2x plus y is equal to minus 1. So here y will be 2x minus 1. 2 into what is x? X is 1 minus 1, so y is 1 again. And at last we can find out, uh, yes, at last we can find out z. So it is I to the power minus 2x. So now I'll directly write the power. So minus 2xy plus y plus z, and here on the right hand side there is no I, sorry, on the left hand side there is no I, so it is 0. So just put in the values to find out z. So you will get it will come as plus 2x minus y. So x is 1, so 2 into 1 minus 1 is 1. So we have x is equal to 1, y is equal to 1 is equal to 1, z, right? So everything is 1, so that if we put in the main formula, so how this momentum is related with, let's choose some other color. So how this momentum is related with mu naught? So mu naught to the power x, which is 1, q to the power 1, and I to the power 1. So it's mu naught qi, right? And if you look into the option 2 is correct. So I hope you could understand this problem. This is very easy, but again you need to be very uh, interactive, not interactive, I would say. You should be able to, you should be calculative enough to find out all these things. One small mistake can lead to, a big loss. So just try to solve as much question as you can, and then after you can easily do it. So yeah, if you liked it, please, I'll be happy. Thank you.